Alright guys, this is the beginning of the Chapter 4 review video for Geometry AB. Excuse me. This chapter starts with the different types of triangles you can have and ends with proofs. So we're going to start and do the odds only. Number 1, you have all inside angles of a triangle. One thing we know about all of the angles in a triangle is that they all add up to 180. So I would write the equation x plus 75 plus 48 equals 180. I'm going to combine my like terms. 75 and 48 add to give me 123. So I would say x plus 123 equals 180. I'm going to subtract 123 from both sides to leave me with x equals 180 minus 123 is 57. Since x is representing the whole angle, this x gets a degree sign for its answer. Number 3, if you flip over to number 3, we have a right triangle and a little extension on the outside. Since we have more information surrounding x, we're going to start in this triangle. This angle right here is a right angle, which means it's 90 degrees. And we have another angle that's 36 degrees. Since x is inside the triangle with all two of those angles, we know that they all three add to 180. So I'm going to write the equation x plus 36 plus 90 equals 180. I'm going to combine my like terms. 36 and 90 adds to give me 126. So when I subtract 126 out from 180, that gives me that x is 54. Since x is 54 degrees, x and y are vertical angles. Vertical angles are always going to be congruent, so y would also be 54 degrees. Number 5. Number 5 has a triangle inside and a linear pair next to that. Since all three of these angles are inside the triangle, I'm going to add them up to equal to 180. So I would say 48 plus 54 plus x equals 180 degrees. 48 plus 54 is 102, so I combine those like terms to say 102 plus x equals 180. I'll subtract 102 from both sides. That gives me x equals 78. So x is 78 degrees. The next thing I would notice is that x and y form a line. They meet together at the same vertex and form a line, which means that they are going to be supplementary. So I would take 180 degrees and subtract out the 78 that we know. 180 minus 78 is 102. So y would be 102 degrees. Number 7. Number 7, when I identify that type of triangle, it is isosceles because we have two congruent sides. Because we are given information about the angles, I want to interpret what does that tell me about an isosceles triangle in terms of angles. Well, we have two congruent sides, which means we have two congruent angles. The two congruent angles are always across from the sides that are congruent. So these two values are the same. All three of them should add up to 180. So if I take 180 and subtract out the angle that we know that's 70, that leaves me 110 degrees for A and B to share evenly. So if I take 110 and divide that evenly by two angles, that gives me 55 degrees for each angle measure. So x and y are both going to be 55 degrees. Number 9. I have two triangles in this picture. The one that I have more information about is this bottom one. Even though I have numbers in both triangles, this triangle on the bottom gives me more information because they have two sides congruent, which means the angles across from them in that triangle are also congruent. So z and x are going to be the same measure. Since all three of those angles should add to 180, I'm going to take 180 subtract out the 110 that I know. So that means that each angle is going to equally share 70 degrees. So I'm going to take that 70 and divide it evenly between the two angles, which gives me 35 degrees. So that means that Z is 35 and X is 35. The next thing I look at is that we have a pair of parallel lines here and here. Now, when I trace over the line that is the transversal between them, I can relate, that allows me to relate angle Z to angle W because those are the angles that are sandwiched between my parallel line and my transversal. Sandwiched between the parallel line and the transversal. W and Z are alternate interior angles, which makes them congruent. So W is also going to be 35 degrees. Now you can't do the same with Y and X because these lines are not parallel. Because those lines are not parallel, you can't relate Y and X. However, now that we have 2 out of the 3 angles on the top triangle, I know that 50 plus 35 is 85. And if I subtract that from 180, that's going to give me this last angle measure. So 180 minus 85 is where I get that 95 degrees for Y. Okay? Next page, number 11. The angles in a triangle are in a 4 to 5 to 6 ratio. Find the 3 angles and classify the triangle. The first thing I would notice is that we have angles in a triangle. And I'd ask myself, what do I know about the angles of a triangle? I know that they add to equal 180. So since I have 3 angles that are given to me in a ratio of 4 to 5 to 6, that means that they relate to each other in 4 to 5 to 6. That doesn't mean they are 4, 5, and 6. If you had a triangle that was 4, 5, and 6, 4 plus 5 plus 6 doesn't add to equal 180. So I need some common multiple, x, that has been simplified out of that ratio that's going to give me my actual angle measures. So I would say 4x plus 5x plus 6x is equal to 180 degrees. So when you combine your like terms, we have 15x equals 180. And then to find what the x is going to be, we need to solve for it by dividing by 15 on both sides. So that means that x is going to be a value of 12. Now that x doesn't have a degree on it because it's not representing the whole angle, but the 3 angles are going to be 4 times that amount, 5 times that amount, and 6 times that amount. So 4 times 12 gives me one angle of 48 degrees. And then 5 times 12, I can't write very well today. Five times 12 is going to give me 60 degrees for one angle. And then 6 times 12 is going to give me the last angle measure, which would be 72 degrees. A good check is make sure 48 plus 60 plus 72 add to 180, which they do, so that's a good check. So we answered the first part. We have our 3 angles right here. The second part says to classify it. When you classify a triangle by angles, you either have acute, right, or obtuse triangles, or you could have equiangular. We do have one angle that's 60 degrees, but all the others are not also 60 degrees. But one thing I do notice is they're all less than 90, so I would call this an acute triangle. All right, moving on to number 13. Number 13 talks about triangles being congruent. Now remember, that triangle congruent statement allows me to see which pieces are actually congruent to each other based on their location in the statement. So for example, angle A is the first letter or the first name of triangle ABC. That should be congruent to the first name of triangle DEF. So angle A and angle D are congruent. Angle B is the middle name Angle B should match the middle name of the triangle in the second one, which would be E. So B and E are congruent to each other. And then C is the last name of the first triangle. It should match the last name of the second triangle, which is F. So angle C and angle F are congruent as well. Now because 50 degrees is the only angle in that first triangle, but I have more angles over here and more information over here, I need to relate that 50 degrees to something in the other triangle. We just said angle A was congruent to angle D, so I'm going to put a 50 degrees there because they're supposed to be the same. One thing I know about 50Z and 60 is that they all three add to 180. 50 plus 60 is 110. And if I take 180 and subtract out that 110, that leaves me 70 degrees left for Z. There's no blank for Z, but there really should be. So let's put a 70 on a blank Z. The other thing we want to find is X and Y. X is the side that connects A to C. So that's a first name, last name segment. So I need to connect first name, last name of the second triangle. That means it is congruent to DF. So X and 40 are the same, which means X has to also be 40. Y is on side EF. EF is a middle last name, so that should be congruent to middle and last name of this first triangle, which would be BC. So BC and Y are the same measure, which means Y is 32. X and Y don't have degrees because they're outside of the triangle, and they're representing side measures. All right, number 15. Number 15 has that quadrilateral ABCD is congruent to quadrilateral FGHK. Again, you want to use the same idea that the sides or the letters in the same position are going to be congruent to each other. The first thing they want us to find is X. Now when I look at this problem, I see X in two spots. One of them is in an expression with Y. One of them is X by itself. I don't know Y yet, so I shouldn't use this equation or this expression because it's not going to help me get anywhere in solving for an actual value. So I want to use 3x minus 6. 3x minus 6 is outside of this figure, which means it's representing a side. Now GF, according to the name, the statement, is the first two names of that shape. So the first two names should be congruent to the first two letters of the second shape, which would be side AB. Those two lengths are supposed to be the exact same, which means the measure 9 should be equal to the measure of GF, which is 3x minus 6. So when I solve this for x, I'm going to add 6 to both sides and get 3x equals 15. Divide both sides by 3, which gives me an answer of x equals 5. The great thing about solving for x first is the fact that this angle that has y in it also has an x. So now I know that that x is 5. So if I replace 4 times x plus 2y, and instead of putting x, put a 5 in there, that makes this angle expression 20 plus 2y. And that angle that it's representing is angle K. K is the last letter in the name. It should be congruent to the last letter in the first figure, which would be angle D. Since their measures are 20 plus 2y and 44, that means in order for them to be congruent, they need to be the exact same value. So I do 44 equals 20 plus 2y. I'm going to subtract 20 from both sides to get 24 equals 2y. And when I divide to get y by itself, we get y equals 12.